This video is sponsored by Edukaji. For more free SPM video, log on to Edukaji site. The link is in the description below. Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM Actual Paper 2023, and this is paper 1. Okay, so let's get started with question number 1. This is from Form 4, Chapter 5, Progression. So here you're given 4 consecutive terms of a sequence. They are 50, 45, x, and y. So you're supposed to state the value of y minus x if the sequence is an arithmetic. Now, if it's arithmetic, remember arithmetic progression, they have the same common difference d. D is your t2 minus t1, or t3 minus t2, or t4 minus t3, and so on. Now, guys, since you're finding y minus x, you can see here, my y minus x is this. Y is your t4, x is your t3. So y minus x is basically your t4 minus t3, correct? Now you can also use x minus 45 and equals to 45 minus 50, but I think it's easier to use 45 and 50 because you want to find the value. So, you know, if you write x minus 45, you're not actually finding the value, right? Your answer will be in terms of x. So it's better to just use t2 minus t1. Now, you don't even have to write this. We can straight away write y minus x equals to, what's your t2? 45. What's your t1? 50. So 45 minus 50 is what? Is negative 5. Yeah, very simple for 1 mark. All right. Now, second part, state the value of y over x if the sequence is a geometric progression. If it's geometric, right, it must have the same common ratio. Common ratio is what? t2 divided t1 must equals t3 divided by t2, and so on. Now, here we can't use what they call that, subtraction. We use division. These two. This is a t4 divided by t3. It must be the same as t2 divided by my t1. So my t4 is y, my t3 is x, my t2 is 45, second term, t1 is 50. So when you did 45 divided by 50, you can just divide top and bottom with 5. You will get 9 over 10. There you go. That's your answer for part B. All right, question number 2. This is from Form 4, Chapter 7, Coordinate Geometry. Right. So diagram shows 2 straight lines. Find the value of q. So you notice that they give us the equation of both lines. First one in terms of q, second one in terms of p. Now the second one is in what we call intercept form. I hope you still remember x over a plus y over b equals to 1. What is a? A is my x-intercept. What's your b? B is my y-intercept. Right? And when you see this 90 degree, we know we have to use what? m1 dot m2 equals to negative 1. That means the gradient of these 2 lines multiplied together is negative 1, or they are perpendicular, right? So, but first you need to find what is the gradient of this first line, right? So we're going to identify what is your p. P is your y-intercept, right? What's your y-intercept? Your y-intercept is 2. But you don't really need to find p. The question didn't ask us to find p. The question asked us to find q. So let us find the gradient of first line. Gradient of first line, m1, gradient of this line here, we use negative. Okay, remember this formula now. Gradient, we can calculate many ways. We can use y2 minus y1, x2 minus x1, or we can use negative y-intercept over x-intercept. I prefer to use this y-intercept over x-intercept because I know my y-intercept. My y-intercept is 2. So I put a negative 2. I know my x-intercept, guys. What's my x-intercept? Your a x-intercept is 6. So your m1 is negative 1 over 3. Now, for m2, look at this line. This is in the form of y equals to mx plus c, where your m2 itself is what? What's m2? My m2 is q, right? The gradient is just q. Since they are perpendicular, we're going to use m1 dot m2 equals to negative 1. Your m1 is negative 1 over 3. Your m2 is q, the result is negative 1. So multiply over what's your q? My q is 3. Okay, moving on to question number 3. This is from Form 4, Chapter 6, Linear Law. So diagram shows 2 straight lines L1 and L2. And they are drawn on based on 5 points plotted on the plane 1 over y against x squared. So which straight line is a suitable line of best fit? Give a reason for your answer. So you can see from here, L1 passes through 1 point, 2 points. This L2. This is L2, right? Whereas L1 passes through how many points? 3 points. To be exact, not exactly 3, it's 2. It's more balanced, right? You can see this point is actually this line here. This is on the line, this is on the line, this is slightly below, this is slightly on top, this is slightly on top. So you can see the points are closer to your line of best fit compared to L2. L2 is a little bit further. Let's show you again. Now let me use a different color. You can see L2 is here, right? Where, yes, these 2 points are on the line of best fit, but these 2 points are quite far from the line of best fit. This point is okay lah, yeah, around there. So how do you explain your answer? Right, so we can say L1 is more suitable. Why? Why is it more suitable? You can say the points are closer to the line of best fit as compare. Don't use as compare, use compare to L2. Okay, now in this case, actually we cannot say that the more points lies on the line best fit, because this point doesn't actually lie on line best fit, right? So for both lines, they have the same number of points lie on line best fit, but for L, right, you can see the points are closer, whereas L2 the points are further, right? So we cannot say, oh, they have the more points lie on the line best fit, right? That's not very accurate, right? So it's just that the points are closer. Okay, that is part A. Yeah, just one mark. Next one. Given that 10, 9 lies on the line of best fit, express y in terms of x. Right. We know we need to find gradient first, right? So which point do I use? Can we use this 2, 4? No. Why not? Because 2, 4 not on the line of best fit. This is like a trick question. 10, 9 is on the line of best fit. So we need to use these two coordinates. Now remember, to find the equation of the line of best fit, you must first find the gradient and your y-intercept. So for my gradient, right, I use y2, which is 9, minus y1, 7, x2, 10, x1, 6. So 9 minus 7 is 2. 2 divided by 4, the gradient is half. Then we find our y-intercept. So for y-intercept, you can use the coordinate geometry, y minus y1, mx minus x1, or you can use the form 3 method, the normal maths method, y equals to mx plus c, where you need to sub in a coordinate and your gradient. Your coordinate, you can use any point, 6, 7, your favorite, or 10, 9. Okay, I'm going to use 6, 7, okay, since you're like this number, right? 7 equals your gradient is half, your x is 6 plus 3, half times 6 is 3, right? Bring over, c is 7 minus 3, c is 4. So your y we can rewrite as half x plus 4. I got my y in terms of x, in the form of y equals mx plus c, a linear form. But then, everyone, what are we finding? We're finding y in terms of x. This big y represents the variable in your y-axis. This big x represents the variable in your x-axis. So your big y is 1 over y. Your big x is x squared. So our goal is to solve for y, find y. Now, one of the common mistakes I always see a student make is that they think that this one, they can invert one by one. They can invert 1 over y, invert it, becomes y over 1. Invert this becomes 2 over x squared. The invert this becomes 1 over 4. This is wrong, huh? Why? Ask yourself this question. If 2 plus 3 equals to 5, can I say 1 over 2 plus 1 over 3 equals to 1 over 5? No, definitely wrong. 1, 2 plus 1, 3 is 5 or 6. So you cannot invert term by term, just like you cannot square 1 by 1, yeah, or you cannot square root 1 by 1. What we can do is we treat this like a single fraction. If this is a single fraction, 2 plus 3 over 1, yes, when you invert, you're getting the same answer. This is true. This is mathematically correct, right? So you can't invert term by term, 1 by 1. You need to first combine this as a single fraction. How? Well, we can multiply top and bottom by 2, times 2 by 2. Because when you times 2 by 2, you're effectively multiplying 1. You don't change the value of the whole equation. So this is x squared plus 8 over 2. This is still 1 over y. Lastly, what do you do? Invert, you get y, 1 over y invert becomes y over 1, which is y. Invert this is 2 over x squared plus 8. There you go. You got your y in terms of x. So question number 4, this is from Form 5, chapter 6. Okay, yeah. So this is trigonometry. So number 1, what we need to do is we need to find tangent beta. So we have to, perhaps it's easier if I label from your diagram. I draw this down. What is your x value here? Look, so x value here. Your x value is negative b. What's your y value here? Your y value is q. So here you can actually just map this onto your triangle. As in, look at this triangle. The triangle goes like this direction, where this is your beta. The length measure from here to here is q. This is negative p, right? Negative p represent the distance measure from here to here. Right. Now, it is negative because it's on the left-hand side of the y-axis. But we cannot put negative p here because the length is just p. So today, if I ask you what is tangent beta, we use a simple SOHCAHTOA. Tangent is what? Opposite over adjacent. This is your opposite. This is your adjacent. This is your hypotenuse. Okay. So what is your opposite now? Your opposite is p. Your adjacent is q. Your answer, tangent beta, is just p over q. Very simple. Just read from the triangle. Now, do you put a negative in front of the p? No. No negative, because we are just finding the ratio of your opposite over adjacent. It's a right angle triangle and beta is an acute angle. Right? Okay. Next, part B. By the way, they say this is a unit circle. Unit circle simply means it's a circle with a radius of 1. So it looks like this, but we don't really need that 1 there, right? We don't need the value. Next one, cotangent 180 plus beta. Right, cotangent, as definition of cotangent, cotangent is 1 over tangent. There is a 180 plus beta. Okay, 180 is measured, remember for trigonometry, angle is measured from positive x-axis. So 180 will be up to here, right? So beta is an acute angle. You can see it's a small angle here. So we go a little bit more. So this will give us 180 plus beta. So beta is this small angle here. So you notice this lies in quadrant number 3. So we're going to apply the ASTC. Remember ASTC, all science teacher crazy. Yeah, that means tangent is positive in quadrant number 3. So when you want to find this value, this 180 plus beta is your general angle. We have to express in terms of your reference angle. Your reference angle is just beta, this small angle here. Yeah, general angle is the whole thing, this measure from here to here. Reference angle is this small angle here, which is beta. So we just read tangent beta. But you need to remember, if this is quadrant 3 and is sine, if it's sine, you need to put a negative. If it's cos, you need to put a negative. Because in this sequence, ASTC, quadrant 3, only tangent is positive. The rest are negative, right? Now, let us read tangent beta from part A. Substitute inside 1 over P over Q. You flip it upside down. Your answer is just Q over P. Okay, question number 5. So this one is vector, form 4, chapter 8, vector. Okay, diagram shows 3 points on the Cartesian plane. You're supposed to find SP. Okay, so if you look at the diagram, right, where is SP? SP is here to here. So we can go S to O, O to P. You can use the addition of vector, S to O, followed by O to P. This way. Okay, so let me write here, this is part A, SP is SO plus OP. Your SO is just basically negative OS plus OP. Since you're given coordinate point as 1, 2, that means this will be what? Negative of 1i plus 2j. We just write in ij format. Remember, 1i means 1 unit to the right, 2j means 2 unit up. Then you plus with OP. OP is what? Minus 1i, because it's going left, right, negative 1, plus 5j. Let's put them together. Negative I minus 2j minus I plus 5j. The result is minus 2i plus 3j. Okay, that is vector SP. Yeah, quite okay, quite simple. Right, second one. They say given that PQ is plus, given that PQ is now 5 plus mj and SP plus 3PQ is 13i plus 15j. Okay, so let me do it here. We know SP from the first part, so it's minus 2i plus 3j. You add with 3PQ, your PQ is 5i plus mj. The result is 13i plus 15j. My goal is to solve for m. So let's expand this bracket one by one. You get minus 2i plus 3j plus 15i plus 3mj. The result is 13i plus 15j. Now we can put these two together. These two can cancel. Okay, minus 2 plus 15 is just 13, right? You can simplify it. 13i. Whereas the j component, 3j and 3mj, we can put together. You will get 3 plus 3mj. The result is 13i plus 15j. So we just have to compare our j component. I component doesn't matter because we can cancel them off. The 13 can cancel them off. Just compare these two. We have 3 plus 3m equals to 15, right? 15 minus 3 is 12. 12 divided by 3, m is just 4. Okay? Alright, now that you know m equals to 4, we can now find the, what we call unit vector in the direction of PQ. Right, so unit vector is a vector divided by its magnitude. So we need to first find what's the magnitude of PQ. Since I know m is 4, so PQ will be 5i plus 4j. Alright, we take PQ, find the magnitude. So it's 5 squared plus 4 squared square root. So it's 25 plus 16, that will be square root of 41. You can use your calculator. If you can't do mentally. Now, normally we don't write PQ arrow with a cap on top. Yeah, normally we don't write that, right? Unit vector, we normally just write a vector like this and then put a cap, the small letter. So here, let me just, up to you, want to call it U for unit vector, cap here. Take 5i plus 4j, divide by the magnitude. What's the magnitude? Square root of 41. That's it. Question number 6, Form 4, Chapter 1, Function. This involving modulus function. Diagram shows the graph of function fx equals to modulus x minus 3 plus 1 for the domain of x between minus 2 and 7. So find the value of the other object h. Okay, h is the image for 7. The other object will be here. You move across, you move down, should be here. Right? So this question will be unique because modulus function that they give in SPM usually usually it will touch the x-axis, right? But this one, they plus 1, they shift up by 1. So it looks a little bit more difficult, but it's okay. Calculation is not too difficult. All right. So we begin by solving for h. We're not finding h, right? We're finding the value of the other object of h. But first we find what is h. H is your y value, which is your fx value. So we sub inside modulus of x plus 3 plus 1. Okay. Maybe I write this first. H is your y value when your x value is 7. So we say f7 equals to h. Let us put 7 inside your x. 7 minus 3 plus 1 is h. 7 minus 3 is 4. Right? 4 plus 1 is 5. Right? Modulus of 4 is, okay, let me write here. Modulus of 4 is 4. 4 plus 1 is 5. Your h is 5. But guys, I'm not finding h, I'm finding what? I'm finding the other object of h, which is my x value. So we now take your fx, let it be 5, which is your h here. We're finding the second value. So we start by writing modulus of x plus 3 plus 1 equals to 5. Bring the 1 over to the right. 5 minus 1 is 4. Whenever you open up modulus, always remember two answers. One is positive, another is negative. Right? So we write the negative first, followed by the positive. So as I transfer over, my x is now negative 1 or 7. Okay, which one should I take? Which one should I skip? We should take negative 1. How come I cannot take 7? Well, 7 is the original value here. This is 7, right? Second one should be here, right? Negative 1 should be here, right? So we know x can't be 7. Therefore, x is negative 1. Moving on to part B. This one is using a composite function and inverse function. Okay, so the first part they say, given that fx equals to 4x minus 1 and gx is 3x plus 2x plus 3, find p if f inverse p equals to 2. Now, I know a lot of people are going to inverse the function, but actually you don't have to inverse the function. Why? You see, when we say f inverse p equals to 2, meaning you start from p here, you go backwards. When you go backwards, you end up at 2, correct? If you go forward, we start from 2, you end up at p. So you just basically switch the position of your object and image. You don't have to inverse the function, right? If you're finding p here, I rewrite f2 equals to p. Let's put 2 inside your f. So p is 4 times 2 minus 1. 4 times 2 is 8. 8 minus 1, p is just 7. Okay? Simple. Next, find the value of x if fgx is 5 times of f2. Now, actually, we got your f2 with your f2 is your p, right? Your f2 is your p, which is 7. So we can start by writing fgx equals to 5 times 7, because your f2 is 7. Then we are supposed to find x, right? fgx means composite function of putting gx inside fx. What's my gx? My gx is this 2x plus 3. This is 5 times 7, 35. Now take this bracket, put inside fx. Okay, you got to think bracket. Fx is 4x minus 1. So if I put 2x plus 3 here, I must put 2x plus 3 here. So you have 4 of 2x plus 3 minus 1. The result is 35. Now, how you want to continue solving from here is up to you. Some people, they expand the bracket and simplify first. Some people throw the 1 over first, up to you. So let me do a bit of mixed method. I times inside this 2, I get 8x plus 12. I transfer the 1 over, 35 plus 1 is 36. Then what I do next, I bring 36, I bring a 12 over. 36 minus 12 is 24. 24 divided by 8, my x is 3. Okay, question number 7a. So this is which chapter? Form 4, chapter 2, quadratic function. So the first one you have, part A, part B, part C. Part A first. Diagram shows a curve and a tangent to the curve. Express P in terms of C. So they show you that the line is a tangent to the curve. Means what? Means what? When you solve it simultaneously, you have how many real roots? 1. Okay, remember, if it crosses at 2 points, you have 2 real roots. It touches at 1 point, 1 real root. If it doesn't intersect, you have no real root. Okay, so in this case, you should have 1 real root. But before we talk about the real root, we need to first substitute this inside. Maybe we call this equation 1, call this equation 2. We sub, let's say, 2 in 1, 1 in 2 doesn't matter. We write negative x plus c equals minus 2x squared plus 3x plus p. Now, I prefer to throw everything to the left because I like my coefficient x squared to be positive. But if you throw to the right, it's okay right now. Minus 2x squared bring to the left becomes 2x squared. minus 3 minus x bring over minus 3x is minus 4x. Then you have c minus b equals 0, right? From here, we're going to do b squared minus 4ac. Why? Because you have how many real root? One real root, one solution. Okay, so your b based on this is negative 4. Remember, b is the coefficient of x. Your a is your coefficient of x squared. Your c is just c minus b, the constant. Our job is to find what? Is to find b in terms of c. Now, I know a lot of people tend to multiply inside. You can, but I like to simplify further. Negative 4 squared, 16. 4 times 2 is 8. C minus b. I prefer to divide by 8. Make the number smaller. 2 minus c minus b equals 0. Understand this? Right? You can throw the c minus b to the right, or you can multiply inside. So if I multiply inside, I get 2 minus c, minus minus becomes plus b equals 0. Since I'm finding p in terms of c, I throw everything to the right. Your c becomes positive, 2 becomes negative. Your answer, p is now c minus 2. Okay, 7 part B. So this one is the quadratic inequality. But here they specifically mention using the table method. Do you still remember how to use the table method? Right. Number one, we go to expand the bracket. 1, 2, 3, 4. Let me expand slowly. 3x squared, there's a negative here. Then minus 3x minus another 3x minus 3 less than x minus 1. So you have minus 3x squared minus 6x minus 3 less than x minus 1. So you either throw everything to the left or throw everything to the right. Now, I know a lot of people, when I throw to the right, they find it a bit complicated, a bit confusing for them. So now I throw to the left first. Minus 3x squared minus 7x minus 2 less than 0. But one of the things I always see a student try to factorize in calculator here, and they make a mistake. Because if you factorize in calculator and then you write in a bracket, right, your answer is not going to be the same, right? Because you expand, you're not going to be the same. And the symbol will change whenever it times and divide with negative. So be careful about that. Right? For me, I'll just multiply with negative 1. Get rid of negative. It's easier to do it if this is positive. But when you multiply negative, what happened to this symbol? The symbol will change. Now, we have to take 3 times 2. Okay, I hope you don't use calculator. I hope you use brain. 3 times 2 is what? 6. What's the factor of 6? I want to get 7. 6, 7. 6, 1. Some more? 3, 2. The one that gives us 7 is 6 plus 1. So we put double bracket like this. This is 3x, x. To get 6, it looks like this. This must give us 6. This must give us 1. So you put 2 to get 6x. You put 1 to get 1x. And because I want positive 7, so both must be positive and positive. Right? So up to here, yep, we factorize it. We can continue and solve it. But there are 3 different methods actually, if you remember. Graph, sketching graph, number line, table. Here we want table. Now, before you use table, right, we need to identify the roots and the region. So the roots happens when this whole thing equals to 0, right? You can write let this be 0. So your x is negative 1 over 3 and negative 2. So we need to break this up into 3 different regions, right? By using a table like this, right? So the first part, okay, I think I move this to the right a little bit. I need a bit more space here, right a bit. You need to break up into 3 regions. 1, 2, 3. Okay, so the first part, right? You notice negative 2 is smaller. Negative 1 over 3 is bigger. So negative 2 is here. We take x less than negative 2. Then, in between negative 2 and negative 1 over 3. Next one, more than negative 1 over 3. if you're unsure about this, right, you can just do a sketch. Graph, we are so familiar with graph, right? The graph looks like this. Okay, so less than -2, between -2 and -1, 3, more than -1, 3, 3 region. Then we're going to put the first bracket first, then the second bracket, and the third one, these two multiply together. Draw a line like this. Okay, so we are going to take a number and substitute inside. Okay, maybe I can show you using a calculator. You don't actually need to use a calculator, but I know a lot of students who prefer to use a calculator. Okay, I use a calculator here, right? Now, we start by typing this 3 alpha x plus 1. Yeah, if you're using the latest calculator, right, the X button is below the on button, right? So you pick a number here. Pick a number less than -2. Press calculate. The easiest number is -3. You notice it's negative, right? So if you don't know what I'm talking about, it's this. We put a number inside -3. You plus 1. You get -8, right? Which is what I've shown you in your calculator. So the exact value is not important. The important thing is the sign. Less than -8. I mean, -8 is negative value, right? Okay, then we pick a number between -2 and -1, 3. The easiest number is 0. Put 0 inside. If you put 0 inside, it's 3 times 0 plus 1, which is just 1. So it's positive. Then take a number more than -1/3. Wait, I made a mistake. It's not 0. Negative, so we better take -1, not 0, sorry. -2 and -1/3, the in between value is -1. So you get -2, right? This is also negative. Pick a number more than -1/3. Maybe I put 0. You will get 1, which is positive. Then we move on to x plus 2. X plus 2, yeah, easy. Put -3 inside. -3 plus 2 is -1. So it's negative. Put the -1 inside. -1 plus 2 is 1. So it's positive. Third, pick a number more than -1/3. The best is 0. 0 plus 2 is 2. Positive. Now remember, the table method, basically, we are finding what is the sign for the first factor, then you multiply with the second factor. So the idea is this: if you have a positive number, you multiply a positive number, your answer is positive. A positive number times a negative number, you get, sorry, I should put a single, you get negative. And negative number times negative number, a positive number, you get negative. Negative times negative, you get positive. So you find out the multiplication of these two, which one gives us positive, which one gives us negative, right? So you see this way: negative times negative is positive. Negative times positive is negative. Positive times positive is positive. But go back to your question. What are we finding, guys? We're finding positive or negative. We are solving this inequality. This inequality is positive. So which part of your table is positive? Which region? Here and here. Positive sign, right? Since we want more than 0, positive, therefore your answer is x less than -2, x more than -1/3. I know, right? This method is really, for me, it's really silly. Use graph is a lot faster, right? The table method, you can show so much working. But what to do? The question asks us to use this method. You have to really show this. You can't use any other method. Part C, this one, you have to use the SOR, POR method. All right. So P and 2P are the roots of this equation. Find quadratic equation with the roots of P minus 1, P plus 1. Okay, now what you can find out what's your P. So if this is the root, right, we are given the root, we're given the equation. So when you see this, we have to use SOR, POR. For example, you can say this is your alpha, this is your beta, that's the method. So let's begin with sum of root, alpha plus beta. Yeah, alpha plus beta is negative b over a. So p plus 2p is 3p. 3p is -3. P is -1. All right. Now that I know my P, right, we can straight away find your new roots. Okay, don't need to do POI anymore because it's important. We want to find P so that we can identify your new roots. The new roots are based on this P minus 1, P plus 1. So what is your new root now? Negative 1 minus 1, negative 1 plus 1, which gives us minus 2 and 0. Right, so if you know your new roots, we can find your new SOR. Very easy. SOR is these two. Add together, you get negative 2. Find your new POR. Take these two, you multiply together. When you multiply with 0, you get 0, right? And remember the equation to form a quadratic equation is x squared minus SORx plus POR equals 0. Remember this equation? We write x squared. Your new SOR is negative 2. X. Your new POR is 0. So minus minus, you can write plus 2x equals 0. Now, by the way, I know people may say, can we just expand the factor? Yes, we can, because you know that the root is now minus 2 and 0. Can we just say x plus 2, bracket, this one is x, times together equals 0, expand the bracket, you will get a new quadratic equation. Yeah, you can as well. Yeah. Okay, question number 8. This is from Form 4, Chapter 5, Progression. So here they say listing out all the terms of the sequence it is not accepted, so you cannot list one by one, right? So here we have a cylindrical wooden block cut into pieces for decoration purpose. Diagram shows the first 3 pieces and blah blah blah. We cut. So angle increased by a constant amount. Okay, so here what we want to do is we want to find the angle for the smallest p, small a. They give us these two information. Number one, the angle for sector of the fourth piece is 3 times angle of the smallest piece. The smallest piece, we let it be D1 or A, right? Maybe I write here. The fourth piece, D4, is 3 times D1. Remember this arithmetic is increasing with a constant angle. Dn, remember, is A plus n minus 1d. My A, I don't know. N minus 1, 4 minus 1, d. Your D1 is A. So we can write A plus 3d is 3A. Bring your A over. You can say 3d is 2a. Now, I don't know what to do. Should I make a as a subject? Perhaps, yeah. We'll leave it first. We look at the second information. The sum of angles for the first 4 pieces is 72. That means your S4 is 72, right? Now, can we simplify this? Your A, you remember SN formula? SN is n over 2, 2a plus n minus 1d. So we write this as 4 over 2, your a I don't know, n minus 1d. The result is 72. So this is 4 divided by 2 is 2. You can divide it. 2a plus 3d equals to 72 divided by 2, 36 equation 2. Now I notice I don't have to make one of them as a subject because I already have 3d equals to 2a. So if you are solving for a, we can put 3d inside. Yeah, straight away. Right. So okay, let me just call this equation 1. We sub equation 1 inside equation 2. So your 3d is 2a. So 2a plus 2a is 4a. 4a is 36. Okay, let me move up a bit. So what's your a? My a should be 9. So the smallest piece has angle of 9 degrees. Right? Now, then they say find the n. Okay. What is n? N is your total part. How many can you cut? We don't know. Now, you cannot say your n is, you cannot say total angle is 360 because we may not use the whole block, right? You can't do, you cannot cut anymore, right? So, I think we can. Can we cut? Wait, let me see. they say, okay, can you see this line? A total n pieces can be cut from this block. Yes, we're going to use Sn equals 360. Yeah. So now we should first find your d, because without d we cannot find n. So we sub inside equation number 1, 3d equals to 2 times 9, 18 divided by 3, d, 18 divided by 3, d is 6. All right. Next, part B, I need to do part B here. So once you know your D, you need to find your Sn. So we begin by writing Sn equals 360. The formula is, use back this one, n over 2, bracket 2a, my a is 9, plus n minus 1d, d is 6. The result is 360. So I know a lot of people tend to multiply the 2 over. Can I just divide by 2? Because there's a half here, right? This half I times, so I cancel it. 6, I can divide by 2. I'm left with 3. That will be easier. Simple number. Keep your n. 9 plus 3n minus 3 equals to 360. 3n times n is 3n squared. 9 minus 3 is 6. 6 times n is 6n. Your 360, you bring it over. From here, I'm going to divide everybody by 3. Your n squared plus 2n minus 120 is now 0. Okay, how to factorize? Factor 120. 120, we can use what? 120 a lot. But I think look at this straight away, you can tell, right? 12 and 2, right? Isn't it 12 and 2? 12 and 10. Right? All right. So we know we should use n, 12, 10, positive, negative. N is always more than 0, right? So n is more than 0. N can't be negative, so my n is just 10. Now, we know this is arithmetic, not geometric, because the sector increased by a constant amount. If they say increase by a constant ratio, then it's geometric. Yeah, remember geometric is like twice as long, 3 times longer, or half the length, half the angle. But this is constant amount, keep increasing, steady rate. Question number 9, this is from 4, chapter 4, indices, surds, and logarithms. Okay, the first one is on indices. You're given that 2 power x equals 8 power y equals square root of 2 power 3z. Find x, y, z, the ratio x, y, z. Okay, number one, we need to compare two ratio or two of these together. Either I use the first two, the next two, yeah, up to you, or you can take the first and the last. So let me begin with, I think the first two is easier. First, 2x equals to 8y. You need to find what's the relationship between x and y, right? We know 8 is 2 power 3. All right, so can we compare directly? Your x is 3y. But guys, you're finding ratio, guys, you're finding the ratio. So what can we do? We can say x over y is 3 over 1. Bring the y down. When you bring the y down, you're left with 3. But we write this as 3 over 1. So x is to y is 3 is to 1. Then we compare the next two. Now, you can use x and z. Don't need to compare y and z. I compare x and z. This is 3z. Okay, remember, square root means power half. So we can write this as 3z. I do very slowly. Power half. You times in is 2 power 3 over 2z. So once you got this, we can compare x is 3 over 2z. Bring the z down. X over z is 3 over 2. X is to z is 3 is to 2. Okay, we already have the first one. X to y is 3 is to 1. X to z is 3 is to 2. How about x, y, z? So x, y, z is therefore x first, x is 3, y is 1, z is 2. Okay, can we continue? Question 9b. All right, so this one is indices actually, still indices, right? Number one, you can see there's a 9 and 3. They all can be written as the same base, which is base 3. So I'm going to write 9 as 3 power 2. This is 2b plus 1, right? Then this is 3 power 4. Wait, there's 2pq here that I missed out. Sorry. 2pq, 2pq plus 1. This is 3 power 4 pq minus 3. The result is 732. So we're going to expand this one by one. You get 3 power 4 pq plus 2 plus 3 power 4 pq minus 3. The result is 732. Now, remember, if you want to find p in terms of q, right, you need to get rid of all the base 3. But the problem is, this is 3 power 4 pq with a plus 2. This is 3 power 4 pq with a minus 3. So we know from the laws of indices, right? Like just now when I explained, I'm using the third law or third rule of indices. Remember, when you multiply this, you can times in, you get mn. If you plus, you break up, this one becomes multiply, right? When you minus, you break up, becomes divide. So this is a plus. Let's break it up to multiply. This is a minus. Let's break it up. Becomes divide. Divide 3 power 3. Yeah? Okay. Your base is still 3. The power is still 3. Okay. Now, I know for some people, they find this a bit hard to see. If you find it's a bit hard to see, you can use substitution. Yeah, if you want, you can let 3 power 4 pq becomes, let's say, u. If you do that, probably it looks easier, right? Okay, but you don't really need to. Okay, if you want, I can show you this. This is u now. This is how many u? 3 power 2 is what? 9. 9 u. This is how many u? 1 u. Divide by 3 power 3. 3 power 3 is 27. This is if you were to let 3 power pq becomes u. It's easier to see if you do that, right? Again, like I say, if you don't substitute, it's still okay. Right? Just factorize, just take it out. Okay. All right. Now, how to continue from here? 9u plus 27 of u. I know it's a bit hard for a lot of people. Very hard to count, right? You might want to use a calculator. Come, let me show you your calculator. This calculator. 9 times 27 is 243. Yeah, then you plus 1, 244. So it's 244 over 27p, 27u, this is u, 27u equals 732. To solve for u, right, your 732, you times with 27, divide 244, you should get 81. Okay, so what is u again? U is your 3 power what? 3 power pq. And 81 itself is 3 to the power of 4.
P is 4. 3 power pq.
There's a 4 pq, yes. Okay, sorry, I missed out 4 pq. There's a 4 here, sorry. 4 pq, thank you. 4 pq. So 4 pq is now 4. You're finding p in terms of q. So p is what? 4 divided by 4 is 1. P is 1 over q. Let's move on to part C. This one involving logarithm, right? So remember laws of logarithm. We can use the formula for changing base here. Why? I can see that you have base A and base B. They have different bases. So you're going to change to the same base. Okay, even the formula for changing base, there are two versions. One is the standard version, log AB equals what? Change a new base, C and C. B stays on top, A stays down. The faster version is this. Let me write here. Instead of using base C, right, you can use base B. Because log BB, this is log BA, right? If I put B on top, log BB. What is log BB? Log BB is 1. So basically, we just switch the base and the number. Log base AB becomes 1 over log base BA. So that's what I'm going to do here, because I need to change both of them to the same base. The easiest base to use is AB. AB. You can see they have the same number, but different bases. So now let me change this to 1 over 1 over log base AB A. Guys, I'm using this formula here. I'm switching my original base with my original number, AB and A, we switch. Then this one is 1 over log AB B. So today, if I give you 1 over 3, answer is what? 1 times 3 over 1, which is what? 3, right? So we just invert it, right? So this will give us log ABA plus log ABB. And in the laws of logarithm, remember the first law, like log base A xy, when you break up, it becomes plus. But now we're not breaking it up. We are combining it. So plus combine becomes multiply, correct? This A and B multiply together. And we know log AA is what? Log A is 1. Right? As long as you have the same base and the number, the power is 1, right? Log AB is just 1. Okay, question number 10. This is from 5, chapter 2, a differentiation. So, okay, they say solution other than calculus not accepted, so you can't use any other way except differentiation or integration. Okay, so here on Sunday, most bought a number of spherical ball with a radius of 5 cm. Some ball will be arranged in a single line with a rack with a length of 2.5 meter. On Monday, the volume of each ball decreased uniformly by 20 pi. Determine the maximum number of ball can be arranged on the rack. So when you look at this, right, you'll be thinking, hey, what do I use? Do I use small change approximation or do I use rate of change? Answer is small change, not rate. Rate you must always have upon time, right? There's no time like per second, per unit, right? 20 pi per second or per minute, per hour, don't have, right? So, and then they say each one decrease uniformly by 20 pi. So what is that? The volume, that's a delta V, isn't it? Negative 20 pi. So first of all, what is the volume of a sphere? Volume of a sphere is 4 over 3 pi r cubed. So we can differentiate, right? dV dr is, bring the power 3 down, cancel, you get 4 pi r squared. Okay, so what is your initial radius? Initially, your radius r is 5. So dV dr will be 4 pi 5 squared. 5 squared is 25. 25 times 4, 100 pi. Okay, so my question is, what is the relationship between this, remember this? Delta V, dV dr. We know that delta V over delta R is approximately the same as dV dr when your delta R is small, right? Small means like 0.1, 0.01, 0.5, and so on. You know your delta V. Your delta V is negative 20 pi. You are finding your delta R. You know your dV dr, 100 pi. So 20 divided by 100 is 205, 0. You can use your calculator, you can cancel, let me cancel here, cancel pi and pi. 20 divided by 100, cancel the whole thing, is 5, so it's negative 1 over 5. Negative 1 over 5 is negative 0.2. Okay, that means that initially, this is a spherical ball. Your radius initially is 5. Now, it reduces to what? It reduces by 0.2. You need to find the new radius. Okay, remember, normally we say delta x is what? x2 minus x1, correct? So your delta r will be r2 minus r1. I want to find my r2. r2 is my new r, which is r1 plus delta r. Okay? So what is your r1? r1 is your initial radius. Oh, we know what? Your initial radius is 5, right? So what's your final radius? You can call it r2. Is your r1 5 plus negative 0.2, answer 4.8 cm. So your new radius is 4.8 cm. right? Now, question is this. You have a rack with a length of 2.5 meter. 2.5 meter is 250 cm. Okay? You have each ball like this. It has radius of 4.8. So we need to find what's your diameter. One ball, right, will take diameter. Diameter is 2 times the radius. 2 times 4.8, that will be 9.6 cm. So one ball will take up 9.6 cm of space. So question is, how many ball can we fit inside 250 cm? So number of ball is 250, divide 9.6. Okay, let me use my calculator. This one will be in decimal, cannot be a whole number. Let me just use a calculator. 250 divide 9.6. Answer is 20.06. Okay, now actually this one a bit of a gray area. A lot of people will say 20.06. Should I use 26? Should I use 27? 26. No need to think very hard. You know why? 26 is enough. You can put 26 and a little bit more. Little bit more. So just 26. Not 27. Please don't think the bigger one. Not enough. Yeah, you have enough space for 26 and a little bit more. That's 0.04. So the number of the ball will be just 26. Let's move on to the next one. Okay, next one is slightly easier. This one involving differentiation. They asked to determine the type of turning point justifying your answer. Okay, here since they give us hx, right? I'm going to write h prime x. You can write dy dx, but easier just write prime. Huh? Prime means differentiate once. The first time you differentiate, you get 6x plus 7. The second time you differentiate, you get what? 6. Okay, remember, when you differentiate first time or dy dx, you let it be 0. This represents what? Represent a turning point, or we can say a stationary point. Turning point, you got two. You got minimum or maximum. Stationary point, to be exact, you have also what we call this, anyone know? Point of inflection. Yeah, inflection can be going upwards or going downwards. These are inflection. Inflection happens when d2y dx square is equal to 0. Minimum happens when d2y dx square is more than 0. Maximum happens when d2y dx square is less than 0. So in this case, you can see your d2y dx square or your h double prime is more than 0. So the type of turning point is what? Is a minimum point. That's it. Very simple. Let's continue with part C. This one is integration. Okay. Now here they give us the gradient function of a curve. Gradient function is a dy dx. Okay. So we let our dy dx equals to 2x plus 1 power 3. The curve passes through this point. Find the equation of the curve, arrange your answer in this form. So we know when you differentiate y, you get dy dx. When you integrate dy dx, you get back your y. So this will be 2x plus 1. Increase the power by 1, 4. Divide by 4. Differentiate inside bracket 2 plus c. So I need to find my c value. Okay, let me write one more line. 2x plus 1 power 4. Maybe I write 1 over 8 in front. 1 over 8 plus c, because you need to give your answer in this form where the a is outside. So we sub in 1 over 2 and 5. Your y is 5 when your x is half. So this will be 2 power 4, 16. 16 times 1 over 8 is 2. My c is 3. Your y is therefore 1 over 8 of 2x plus 1 power 4 plus 3. Okay, this is Form 5, Chapter 5, a probability distribution. It is found that the probability that product from company can be sold is this. So this is your small p. The probability is 19 over 20. If in a particular month, the company produces 820 units of the product, your n is 820. Find the mean and standard deviation, right? Okay, mean is given by this. NP. Mean is mu, the symbol is mu. Your N is 820, your P is 19 over 20. Okay, so let's use our calculator. 820 times 19 over 20, that gives us 779. And how about standard deviation? Standard deviation is given as square root of NPQ. I know my N, 820. I know my P, 19 over 20. Okay, how to find Q? My Q is actually 1 minus P, yeah, which gives us what? 1 over 20. You can write 1 over 20 straight away. Okay, use your calculator, square root 820 times 19 over 20 times 1 over 20. You can just put the 20 next to it. You can just times straight away. Yeah? You need to do this. Right, calculator, you should get 6.241. 4 significant figure, 6.241. Okay, so here we have permutation and combination form 5, chapter 4. There are actually two ways to do this. First one. Okay, now I can show you both ways. I think the longer way, I show you the longer way first, then I show you the shorter way. The longer way, they say that 25 students in the class. The teacher wants to choose some student from the class to join the game. So it is given that the number of different ways of choosing R student equals number of different ways of choosing R plus 13 student. So that means 25 choose R is the same as 25 choose R plus 13. So remember this formula, NCR is N factorial, N minus R factorial, R factorial. So here we write 25 factorial, 25 minus R factorial, R factorial. This is 25 factorial, 25 minus R plus 13 factorial with another R plus 13 factorial. Okay, now here's the thing. We can cancel your 25 factorial and 25 factorial. Just compare the one below. Now, before you compare, let's simplify this. This is 25 minus R factorial, R factorial. This is 25 minus 13, which is 12 minus R factorial with the R plus 13 factorial. Okay, so this is an interesting part. I'm going to ask you a question. Today, if I say x times y equals to, let's say, 2 times 3. Let's just say this. Then I say x cannot be 2. Then x should be what? If x cannot be 2, x has to be 3. Now this is very simplistic, but you know why I say simplistic? X times y equals to 6. There are a lot, billion of possibility. But I'm just saying that you can compare this and this, this and this. The reason in this case I can compare is why? Because of the factorial. They were separated by the factorial. Right? So it's not multiplied together, it's a factorial first, then you multiply. But the thing is, you cannot compare this and this. Why? 25 minus R, is it 12 minus R? You try to solve this, what happened? You get 13 equals 0, which doesn't make sense, right? Likewise, your R equals to R plus 13. If you compare this, what do you get? Cancel, cancel, you get 13, right? So we are comparing the wrong thing. So what I will do is, I will switch the position. That is, I write 25 minus R factorial with the R factorial. I compare, let me write R plus 13 factorial in front, 12 minus R factorial. So you have two options. You can compare the red one with the red one, or you can compare the blue one and the blue one. Alright? So let's say I compare the blue one. Your R is 12 minus R. Bring over, 2R is 12, R is 6. Okay, guys, this is a long way. But there is a shortcut, a better way to this. But you need to remember this, that when you do NCR, right, guys? Okay, this one, first you need to understand your concept. Is N factorial, N minus R factorial, R factorial. And if I give you NC, N minus R, this would be N factorial, N minus R factorial, and the N minus R factorial. So you see, the minus, you cancel the R. This one cancel the N. Your R becomes positive, right? So it's N factorial, N minus R factorial, R factorial. So notice that this and this, they share the same result. So we know that NCR is the same as NC n minus R. Example, 9C4 is the same as 9C5. 8C3 is the same as 8C5. 7C4 is the same as 7C3. The thing is, these two add together must equal to n. These two add together must equal to n. These two add together must equal to n7, right? So if you understand this, right, and you know this, and this type of question has been tested in SPM before this, right? We know that if this is true, starting from here, I show you method 2, starting from here, we know this is right. So if 25CR equals to 25CR plus 13, right? Therefore, your R plus 13 must be 25. Your total plus together must be 25. These two plus together must be n, right? So 2R is now 12, R is 6. So you don't need to do so long. Yeah, this method is quite confusing. Yeah, but this is for those who cannot remember this relation. If you know this relation, use this straight away. Method 2 is a lot faster. All right, next one. Number 1, done. I know it's a bit hard for some of you. All right, let's look at number 2. A teacher decided to choose a student to join the game. She wants to choose equal number of boys and girls. The students are to be arranged in a row, find them different ways, the boys, such that the boys cannot be next to each other. Okay, so this method is also quite interesting because you have 4 boys and 4 girls, and your boys cannot be next to each other. So that means the boys must be separated from the girls. Yeah, the boys must be separated from the girls. So how do you make them separated? You put girl, 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 girl. Put the boys here, right? So you're going to fit 4 boys into 5 empty spaces between the girls. So the way of thinking is different. You cannot say, oh, 5 arrange 4. No, I mean 5 boys arrange 4. It's not 5 boys arrange 4. It's 5 empty spaces. I put in 4 boys. Then the remaining 4 girls, I arrange them. Okay, how many ways to arrange the 4 girls? This is 4, 3, 2, 1, or 4 factorial, right? So your answer will be what? Okay, what is 5p4? Let me just work it out. 5p4, calculator. 5p4 multiply with 4 factorial. My answer is 2880. Okay, moving on to question number 12. This is probability distribution from chapter 5. Okay, so a farm produces strawberry. The mass of strawberry are normally distributed given by this. Okay, remember this is your mean, this is your variance. So first part, very simple. State the mean and variance. Okay, this is 3 marks. What's your mean? Your mean is 20. What's your variance? Your variance is 0.5 square. You can write 0.25. Yeah, part A, we are done. Part B diagram shows the standard normal distribution graph for the mass of the strawberries. So the shaded region represents the probability that is between minus alpha plus 40 and alpha. So they say if the shaded region represents modulus of z between k, express m in terms of alpha. Okay, you want m. Okay, remember, the formula for standardization is this: z equals x minus mu over sigma. Z is after you standardize. This is the graph of Z. It's what we call a standard normal distribution, right? After you standardize, you get M. Before you standardize is your X value, right? Now, the question already say this is your X value. Before you standardize, the mass is between minus alpha plus 40 and alpha. So this M corresponds with this minus alpha plus 40. So we're going to sub inside this formula here. The Z value is M, your X value is minus alpha plus 40, you minus your mu. What's your mu? Mu is your mean here, which is what? 20. Divide your standard deviation. Okay, your variance is 0.5 square. Your standard deviation is square root of your variance, just 0.5. Okay, since you're finding M in terms of alpha, so this one, when you divide by 0.5, it's the same as times 2, right? 1 divided by 0.5 is just 2. So I put a 2 here. you still have minus alpha plus 20. You times inside the 2. M is 40 minus 2 alpha. Okay? Right. So this is B Roman 1. I got M in terms of alpha. Okay, B Roman 2, I need a bit more space. I'm going to move up a bit. Right. They say if the shaded region is represented by this, a modulus of Z less than K. And this value is now 0.2662. Okay, this one you can use mathematical table or calculator. So I think before we do that, let me express this in terms of the upper tail. Okay, modulus of Z less than K is this. And this is equal to, the whole thing is 1, right? You need to minus 2 times of this. Okay, this part here, we know the area in between is 0.2662. The entire thing is 1. You subtract the upper tail. So I write 1 minus 2bz more than, what do you write here? This is your k, yeah? More than k. Yeah? You're solving for k first before you can solve for alpha. This is now 0.2662. Okay, let us use your calculator. 1 minus 0.2662, sorry, 1 minus 0.2662, whatever I get, okay, or I do a bit slower, I transfer this over. P, Z more than K, 2 of them is 0. What is this? Sorry, 0.7338, 7338. You take this, you divide by 2. As I divide by 2, 3669. The probability, we call this the upper tail probability, 0.3669. Now we need to work backwards and find K from mathematical table or calculator. If you have the 570 MX, the class-based calculator. Okay, let me just use my mathematical table first. All right. 0.3669. Okay, this is how we read 0.3669. Now, 36, yeah, here, nice number. So read backwards with your Z value 0.34. 0.34. Okay, let me go back to this. Let me write this down. Your K is 0.34. Now, if you have this calculator, okay, I wonder whether you can see this. Wait, let me add in my, okay, this one. Okay, this is my class-based calculator. You press menu, you press this one. Now, this is 7 for distribution. You press 3 for inverse norm. Inverse norm is you're finding the Z value given your area, 0.3669. You should get, okay, there is a point here, there's a point here. You should get, press equals, the rest are all the same, 0.34. Now, although you get negative, we drop it up because your mathematical table is based on upper tail, your calculator is based on lower tail. That's why your calculator has a negative, right? So don't bother about negative, it's 0.34. That's what I've got from my mathematical table. We're not done yet. Now we are finding what you're finding alpha. Okay, just now I standardized the lower tail. I got my M in terms of alpha. Next, I need to standardize my upper tail because your K is your Z value. Remember, I'm using this formula here, x minus mu over sigma. My alpha is my x value. My K is my Z value, 0.34. Alpha minus mean, divide standard deviation. You're solving for alpha. Okay, so let us take 0.34. You multiply by 0.5. Then you plus with 40. What's your alpha? 40.17. Yeah, that's it. This is 20, not 40. So it's 20. It's 0.3. Your mean is 20. So half of 0.34 plus 20. Your answer is 20.17, not 40.17. Yeah, this your mean is 20, not 40. Section B, this is express y in terms of x slash n or e. Okay, the first one I'm going to give you a logarithm. How to get a logarithm? Bring the power ln y power 6 is ln x power square root 5 I bring up, right? Okay, so now I know this question is very weird because you have a square root 5 there. Once you combine to a single logarithm, right, we can combine it. Actually, you know what? The power for logarithm can transfer it up. So your y power 6 is x power square root 5. Now, how to find y? The power 6 you bring over is today if I give you a power m equals to b power n. When I bring, how do I give you m? You power 1 over m on the left, 1 over m on the right. I power 1 over m so that I can cancel m and m. I get my a. Your a is b power n over m. Okay, so when I bring this over, you get x with the square root of 5 over 6. Yeah, the 6 bring over becomes divided by 6. Okay, we understand this up. Now, next, I want to also part 2 express y in terms of x. So we're going to give you a logarithm. So first I bring the 3 to the right. Ln of x plus y squared is now 3. X plus y squared is what? Okay, when you change from the logarithm form to index form, so the normal logarithm is log base a b, or maybe I use log base a y equals to x. So when you change your index form, your y is a to the power of x. But log itself means log base e. So if I say log base ey is x, y is e power x. So this whole thing is your y. If you like, your e, you got to write your base e power 3. Since you're finding y in terms of x, so I'm going to bring my x over, so it's minus x. Then I'm going to square root it. So e power 3 minus x. Okay, let's move on to part B. This is involving sets. All right, so let's begin. Right, okay, I need a bit more space here. Right. Okay, so this one involving sets. This is from 4, chapter 4 as well. Okay, diagram shows the length of a chord BC at a semicircle ABCD. It is given the length of AD is x plus 2 set 2. X plus 2 set 2 is your diameter. All right, and the ratio of the radius semicircle to the chord is 6:1. Okay, this is diameter. So your radius should be what? Your radius should be half, right? So half of x plus 2 set 2 is to the length of this chord. The chord is what? X set 2 minus 1. The result is 6:1. But we cannot write in ratio form, so we're going to convert into fraction. How to write in fraction? Half of x plus 2 set 2 divided by x set 2 minus 1. The result is 6/1. So first we're going to multiply this whole thing over. I'm going to take this whole thing. I multiply up. At the same time, right, the 2 also I can times it over. So I want to cut short my working with x plus 2 set 2 is now 2 times 6 times x set 2, x set 2 minus 1. The 6 you have to times it 2 as well. So I just want to cut short, make it easier. So this will give us 12 set 2x. This is set 2x minus 12. Your left hand side, you have x plus 2 set 2. See, this one we have to simplify set. To simplify set, maybe we bring your x to the right, minus 12 to the left. So you write 2 set 2 plus 12 equals to 12 set 2x minus 1x. Remember, I'm solving for x, so I have to factorize your x, take out the x. You're left with 12 set 2 minus 1. The result is 2 set 2 plus 12. To find x, I'm going to divide this. Is 2 set 2 plus 12 divided by 12 set 2 minus 1. Okay, what we need to do next is to rationalize the denominator. So here we multiply top and bottom with a conjugate. Remember, conjugate of 12 set 2 minus 1 is 12 set 2 plus 1. Okay, multiply top and bottom. Okay, so let's expand this. This is 1, 2, 3, 4 times in 1 by 1. So 2 times 12 is 24. Set 2 times set 2 is 2. 2 set 2 times 1 is 2 set 2. 12 times 12, 144 set 2. 12 times 1 is 12. You divide by 12 times 12. The bottom part is a minus b, a plus b. When you square it, 12 square is 144. Set 2 square is 2 minus 1. Can we simplify further? 24 times 2 is 48. 48 plus 12 is 60. And then you have 2 set 2 plus 144 set 2 is 146 set 2. 144 times 2 is 288. 288 minus 1 is 287. Now the question says find in this form. Now this is a bit ugly number, right? Because you cannot divide further. 60 cannot divide 287, right? So it's okay. We just leave it in this form. So you write this as 60 over 287 plus 146 over 287 set 2. Now, anytime you're not sure whether your answer is correct or wrong, we can use our calculator. Let me just show you how to use a calculator here, right? Let's say, even if you have the latest one, and this one also can, the latest calculator, the class-based calculator even can do this. Let's say I'm taking this 2 set 12 plus 12, sorry, 2 set 2 plus 12, divide by 12 set 2 minus 1, minus 1. As you press equals, okay, I'm sorry, you cannot get exactly, okay, but remember what's this number? 0.9284, right? 9285. Okay, we try this out, we try this, 9285, 60 plus 146, 146 set 2 divide 287. Am I getting the same answer? Yes. Yeah, 9285. So yeah, we know this answer is correct. Yeah, but the answer here is a bit ugly. Your A and B values are ugly. Okay, question number 14. This is from 4, chapter 1 function. So it is given that fx equals to 2x minus 5 and gfx is 4 over 2x minus 5, where x cannot be h. So you're supposed to find the value of h. Okay, very simple. A function becomes undefined when your denominator is equal to 0. Normally we have here, x cannot be this number. So your x value, or your denominator here, 2x minus 5, let it be 0. Bring the 5 over, divide by 2, x is 5 over 2. Therefore, what's your h? Your h is 5 over 2. Okay, first part. Can I? Second one, find the value of x when fx map onto itself. Remember, map onto itself when the image is the same as your object. The image is fx, your object is x. So we take 2x minus 5, we let it be x, bring over x is just 5. All right, can? Okay, part C, you're finding gx. Okay, this is the case where you're given the function inside, you're finding the function outside, right? The function inside is fx, the function outside is gx. So actually you can use inverse method, you can use substitution. Maybe I just use substitution now. We start by letting the function inside becomes y. The function inside fx becomes y. So your gy is now 4 over 2x minus 5. Okay, so guys, do you know your gy? I don't know. In fact, I'm finding gx. But before you find gx, you must first find gy. To find gy, you must change all your x into y. So the question is, what is the relationship between x and y? Well, your fx is now y. That means your 2x minus 5 is now y. Let us make 2x or x as a subject. So actually, no need to do that. This is quite easy. Why? Isn't this 2x minus 5, everybody? This itself is 2x minus 5, right? So can we replace 2x minus 5 with just y? So if gy is 4 over y, gx is 4 over x. That's it, just replace your y with x. Now, the thing is, every time your denominator involving x, we're going to let it be 0, solve for x, and right here, x cannot be 0. Okay, I got my C Roman 1. Okay, C Roman 2, there's a pattern that you have to figure out. Yeah, so you notice there's a g of 4n minus 3. So let us find our g2, g3, g4, right? So you can see here, g2x is ggx. So what's your gx? Your gx is 4 over x. So if you sub, maybe I write g bracket as 4 over bracket. If you put 4 over x inside here, we need to put 4 over x inside here. So this would be 4 times x over 4. Invert this upside down, cancel them, your answer is x. So we write this as 4 over 4 minus x, invert it, 4 times x over 4, you get x. Okay, I think I don't have enough space. I'll have to continue, move down here. Now, this is your G2. Let's do G3. What is G3? Actually, you can tell already from this pattern. G3 means G2 GX. Every G2 it map onto itself. So if I say G2 bracket is bracket, if I put G, what is this? This is G, right? Isn't it? Yeah, G2 x map onto itself. So this is the same as gx. G2 equals to gx, which is 4 over x, right? You can write x not equals 0. Now, how about G4? Oh, G4 is the same, right? G4 is the same as G2. Actually, you can see a pattern really. Every G2 it map onto itself, right? So G4x is G2 G2, which is just x. You just go back to x. Yeah, actually, I don't want to do so many, but I just want to show you because I want to get the 4n minus 3. So you can actually use this diagram here, simple diagram to help you understand. We start from x. You go through function gx. It will map onto 4 over x. So when you do one more round of gx, it will map back onto x. So it's g1, g2, g3, g4, g5. So the odd one will be x. The even one will be 4 over x. So you can say g of maybe I write n x. If n is odd, your gn is now what? Gn is now 4 over x. If n is even, gnx will be x. Now I want to ask you a question. G4nx is odd or even? This is odd. Okay, should I write this first? Should I write this first? 4n itself is even. Like n is 1. 1 times 4 is even. 2 times 4 is even. 3 times 4 is even. They're all even number. But 4n minus 3 is going to be odd, right? Right? Example, 4 times 1 is 4. 4 minus 3, 1, odd. 4 times 2 is 8. 8 minus 3, 5. It's always odd. So therefore, g of 4n minus 3 should be what? If it's odd, it should give us 4 over x, where x cannot be 0. Yeah, I know this part is very long. Okay, last question, question number 15. Now, this one we need to use a calculator, and this is very, very rare because all this one in SPM, trivial graph is sketched. But this year, the 2023, they asked us to plot using a graph paper, and it comes out in paper 1. Normally, it's always paper 2. Okay, so here we have to count one by one. But I have a faster way to do this. You're finding the x value. You're given the x value, find the y value. So I need to complete the table to find the y value. So what I'll do is I transfer this to the right. Your y is 1 minus 3 sine 3 over 2x. So you can sub in your x value inside here to find your y. Now, the thing is, we can use your calculator in what mode? Radian mode, to make it easier. Everybody, shift menu. Your degree radian, choose 4 for radian. Okay, if you're using this calculator, you just press menu. Okay, I hope you can see my calculator. You press, let me go to the normal mode first. You press shift menu, you go to number 2 for angle unit, choose 2 for radian, right? Now then you press menu, go to 9 to get a function, to use a table function. So this is 1 minus, let me see, 1 minus 3 sine 3 over 2x, right? 3 sine 3 over 2x. X is here. As you press equals, you got a second function, don't bother, just press equals again. Start from where? The question starts from 0, right? And if you look at the largest value, largest is 2 pi, smallest is 0, right? Largest is 2 pi, smallest is 0. The step is pi over 6, every pi over 6, pi over 6. You press equals, you will get the whole table. See this? The whole table for you. Done. Right? But for me, this one I have to skip switching. So I would show you again, but I use this calculator so that I can just copy over faster. So I know very few people use this calculator anymore. So you can press shift mode, you change to radian. Here your table function is 7. The other calculator is 9. You type in 1 minus 3 sine 3 over 2 followed by alpha x. You press equals, gx, you press equals, start from 0 and add 2 pi. And the step is the difference. From one to another is pi over 6. So you put pi over 6, you press equals. Now you get this one value. This is 1, negative 0.5. You don't have to put so many decimal because your calculator cannot read so many. I mean, your table, your graph, you cannot read so many decimal point. I think if you put 3 also okay. 3 is also, 2 is sufficient actually. Now, to make it easier to read, right, guys, you can also set your calculator. Like, for example, I can change I put 6 for fix. I fix 2 decimal point. So everything is 2 decimal. You can see, wait, okay, sorry, I typed this wrongly. I didn't realize this is 3 over 2. So 3 over 2x, you press equals. The first one, is 1. So I just typed wrongly just now. So change this for me. First one is 1. Next one, negative 1.12. Negative 1.12. Next is negative 2. 2.00. You can write negative 2. Next one is negative 1.12 again. Next one will be 1 again, 1.00, you can just write 1, right? Next one will be 3.12. Next one will be 4, 4.004. Next one will be 3.12 again. Next one will be 1, followed by negative 1.12, followed by negative 2, followed by negative 1.12. Lastly is 1. Okay, so now that you got all this, we're going to plot this on a graph paper. They say use the scale 3 cm to pi over 3. Okay, all right. So let me plot on the graph paper here on the right hand side, better one to be on the right hand side here. So they say 2 cm to 1.5. So I need 9 boxes horizontally. Horizontal I need 9. Vertically maximum is 4, minimum is negative 2. So maybe I just draw here. This is 4, 3, 2, 1, 0, negative 1, negative 2. Okay, I go down a bit, negative 2. Okay, so I start with the horizontal line here. Okay, so this is your vertical line. Sorry, my line not so straight. This is your y. Okay, the question says 3 cm to pi over 3. So we can see this is pi over 3 plus another pi over 3 is 2 pi over 3 plus another pi over 3 is 3 pi over 3, which is just pi. Then this one will be 4 pi over 3. This is 5 pi over 3. And this will be 6 pi over 3, which is 2 pi. Okay. Now, if you see your maximum, let me start with the first one. First one is 1 and negative 1.12. Okay. 1 will be here. I can plot here. The pi over 6, right, is in between here. This is 15 boxes. So it's a bit weird. It's 7.5. 7.5 is here. Negative 1.12. Negative 1.1 is here. I think you can just put here, negative 1.1. Right? Now, at pi over 3, you will get negative 2. Then you notice I do straight away. You can see this is the pattern, negative 1.12, negative 2, negative 1.2, 1. So it's quite easy to figure out what to do next. This will be down to negative 2. Then it comes back up. So you count 7 boxes from here, 7.5. So around this point here. And then you go back up to 1. Right? Then after that, you go to add 5 over 6 pi is 3.12, and then it goes to 4. 3.12. Again, you count 7.5 boxes. 3.12, 7.5 is here. 3.12 is around here. And then it goes to 4. Okay, did I count correctly? I think I count wrongly. Okay, it looks correct. 7.5 boxes. So this one is 4. Okay, correct. Then it goes back down, right? You can double check your table. It goes back down. Then it goes back down to 1, negative 1.12, and so on. So, okay, 3.12 first. 3.12. 3.12 is around here. 1. And then it goes back down to, this is in between, 7.5 boxes. So it should be here, down back to negative 1, negative 2. Then it comes back up. Over here, should be this point. And then it returns to 1. So there's a pattern here. You can see it goes down, up, down again. So now let me just join together. Now, when you join this, right, use a 2B pencil because the thicker the pencil, the better. Yeah, it can hide all the ugliness, right? So it goes down, up, and up. Okay, it goes up. It goes down, down. This part here I can change a bit. Down. And up. The graph is very time consuming, but yeah. So I bet a lot of people will skip this question and do others. This is section B. You can choose 2 out of 3, right? Guys, my graph is done. Okay, so you slowly draw this. Now, next, I want to state, they say, state the suitable equation straight line to solve this, all right? To solve this equation, right, you need to rearrange this equation such that one side equals to the original graph, which is this one, the y equals to, let me write here, this one. Okay, the other side must equal to a new graph. Okay, because I don't have space, I'm going to just, first, I need to get a negative 3. So I multiply this equation by negative. So it's negative 3 sine 3 over 2x. I times negative on the left. I times negative on the right. So it's plus 2. Okay, now next, I need to plus 1 because there's a 1 in front. So I plus 1 on the left and then I plus 1 on the right. So it's minus 4x over pi plus 3. So your suitable equation of straight line to be drawn is this, but you need to write y here. Your y is now negative 4 over pi x plus 3. Okay, how many points do you need to draw a straight line? You actually need 2, you don't need 3, but then I add in 1 more point just to double check. Because your smallest is 0, largest is 2 pi. I put a pi in between. So picture this, I put 0 inside, I get 3. I put pi inside, 4 pi divided by pi, cancel, negative 1. If I put 2 pi inside, you get negative 8, right? 4 times 2 is negative, there's negative 8, negative 8 plus 3, negative 5. Okay, I think this is out of bound. So this is out because I don't have enough space. I go down to negative 1 only, right? So based on this table, 0, 3, pi, negative 1. So where is 0, 3, pi, negative 1? 0, 3, I'll just use a different color just to make a point. 0, 3 is here. Pi, negative 1 is over here. Use a ruler, join this together, right? So your straight line is this. So this is y equals to negative 4 over pi x plus 3. So we need to find the solution to this equation. Now, because the question say find the solution, right? Yeah. You draw the graph, state the value of x in terms of pi. So this is the annoying part. We normally find the number of solution, but for this question, we have to use a graph to find the exact solution. Okay, look at this. Where's the point intersection? It's here. It looks like in between. So you count the number of boxes. There are how many boxes? 28 and a half. 28 and a half. Not 28, 28 and a half. So what we can do is like this. So we know that 15 boxes or 15 small boxes equivalent to pi over 3. Isn't it? This is 15 and 1 half. So one box is pi over 15 times 3, 45. So you want to find the x value. Your x value here is how many boxes? 28.5 boxes. You times with pi over 45. Now let me use a calculator. Go back to the normal mode. 28.5. Don't need to times pi, because you want your answer in terms of pi. You divide 45, you get 19 over 30 pi. So this is your answer. Well, I think this question is really annoying. To say it's very difficult, no, very annoying, right? Because you have to give your answer in terms of pi, right? And this is your graph. So let me just show you all here, right? I hope you all can draw this. It's not too difficult, but it's very, very annoying to draw, right? Okay, thank you very much for watching this video, right? I hope you guys learned something from this discussion. Hope to see you guys in the next video. Thank you.